Hello, this is Tyler Beamer from Haywood Community College. This is an instructional math video for Math 152 IN1. The purpose of this video is to describe how to compute confidence intervals using the TI-84 graphing calculator. I am going to use the notes as a reference for this video. So here are the Chapter 7, Section 2 notes. Dealing with confidence intervals in regards to estimating a population proportion. These are the notes that are on Moodle. We're going to use example 1 as our problem that we will do using the graphing calculator to find the confidence interval. So it says a study of 420,095 Danish cell phone users found that 135 of them developed cancer of the brain or nervous system. Use the sample data to construct a 90% confidence interval estimate of the percentage of cell phone users who develop cancer of the brain or nervous system. Okay, so we'll show how to use the calculator as an aid in finding that confidence interval. So we would go to Stat, go over to Test, and we want one proportion Z interval, which is A. Okay. Hit enter. Okay. Then we will input our values of X and N. So X, you can think of the number of successes. You know, of course, developing cancer is not really a success, but in terms of the problem, that's what we're studying. So we put 135 there for X. N is the sample, 420,095. And then confidence level is C level, so we want that at 0.90. And calculate. And voila. Calculator does pretty much all the work for you. You've got p hat, which I'm trying to show you, is here, and that matches up with what we got here. This is scientific notation. Our confidence interval is here. This is the lower bound. Once again, that's scientific notation, but that matches up with our answer that we got for p here before we write it as a percentage. And then this is our upper bound, which matches up with the upper value of our proportion before we make it a percentage. Okay, so that's very helpful when finding confidence interval, dealing with proportions. Okay, and then of course you could assess that information in terms of your problem. Okay. I also wanted to take the time to show you how to do confidence intervals with the mean using the graphing calculator. So I'm switching over to the Chapter 7 Section 3 notes, estimating a population mean. So we're going to do a couple of examples here. This is an example of finding the confidence interval, estimating a population mean when sigma is not known, which is what is usually the case. And by the way, these notes show how to do everything by hand, and I've put tables on the Moodle and everything. So, you know, if you don't have a graphing calculator, you can still compute these problems by hand. Will probably enhance your understanding of what's going on, to be honest with you. So we'll use this example as our reference. So in a test of weight loss programs, 40 adults used the Atkins weight loss program. After 12 months, their mean weight loss was found to be 2.1 pounds with a standard deviation of 4.8 pounds. Construct a 90% confidence interval estimate of the mean weight loss for all such subjects. Does the Atkins program appear to be effective? Does it appear to be practical? Okay, so once again, we'll use our calculator to compute the confidence interval. Once again, we go to Stat, Test. In this case, since we are finding the interval of the mean and not a proportion, we want T interval. And we want to choose T interval because we do not know the population standard deviation. We do not know sigma. Okay, so we hit enter. You know, I could do this a couple of different ways. I could input data if I was given data into my list, and then it would calculate it. If I was given a table of data, if I'm given the stats, I just want to use the stats or the information that's given to me in the problem. So X bar, that is the sample mean. So that's 2.1. S of X is the sample standard deviation, which is 4.8. N is 40. And then C level, confidence level, still 90%, so we'll leave that at 0.9. And then calculate, hit enter, and that's going to give us our confidence interval. So let me go down here. So if we match up what we got by hand using the t-statistic and the charts and tables, it matches. So here's our lower bound, 0.82127. Here's our upper bound, 3.3787. So that's very helpful. Okay, I would still recommend knowing how to do this by hand. You know, it's easy to just punch numbers in a calculator, but being able to interpret what that means is important. Okay. The other type of confidence interval we did, so this is one where you would want to do it with the data. So let's just do that real quick. I don't know if I'll take the time to put all that data in, but you would want to go to stat, enter for one, edit, and then you would want to basically type all of that data into L1. Okay, and then go to stat, test, still doing t-test, lost it, well, t-interval, sorry, t-interval, enter, and then you would just go to data, and you already got the data in the list, L1, so we typed all this data in L1, and then put it at whatever confidence level, and then calculate, and it'll calculate it for you. So that's another way to do it if you're given data. Okay. And then to find the confidence interval, estimating population mean, when you know sigma, you know the population standard deviation, which is really rare. I mean, it's rare that you would know the standard deviation and then not know the mean of the population. But if that was the case, you would be using Z instead of T. So we'll use this as a example. So the amount of mercury found in tuna sushi sampled at 7 different stores had a sample mean of 0.719 parts per million. Construct a 90% confidence interval estimate of the mean amount of mercury in the population. If sigma is known to be 0.366 parts per million, assume the population is normally distributed. So then we would go to stat, test, and instead of t interval, we'd use z interval. Once again, you could use data or stats. We're given the stats here. We're given sigma, so we type that in, 0.366. Sample mean, 0.719. N is 7. And confidence level is 0.9. Once again. So calculate, and then that gives us our confidence interval. And you can see that matches with what we did by hand here. Okay. So hopefully this video helps, you know, when you're studying for the final exam, you know, homework quizzes, etc., etc. Like I said, these are going from the notes. I've shown all the work on how to do all this by hand and explanation and whatnot through notes, but you know, the graphing calculator does make this, you know, quicker, a little less cumbersome. So feel free to use this to help you out. All right, hopefully you found this helpful. Have a great day.